All right, we've got to verify another identity. And this is another one where it's not necessarily real clear where to start. But again, like I said, the cardinal rule is to try something. So I'm just going to pick the left-hand side to work on. And I see this 1 plus cosine in the denominator. And I see my target is to turn it into a sign in the denominator. And I know I can turn 1 plus cosine into a sign if I use the Pythagorean identity, right? So remember, again, that sine of squared of x plus the cosine squared of x is equal to 1, all right? So I can subtract cosine from both sides and get the sine squared of x is equal to 1 minus the cosine squared of x. And that's the difference of two squares. So I get 1 plus cosine of x times 1 minus cosine of x. And I'm going to use that to help me solve this, or verify this identity. So what I'm going to do is I'm going to take this left-hand side and I'm going to multiply by 1, but I'm going to use a 1 that looks like 1 minus cosine of x over 1 minus cosine of x. So that when I multiply these denominators, I have the difference of two squares, okay? Because 1 minus cosine of x times 1 plus cosine of x is 1 minus cosine squared of x. All right, so what does that look like now? If I need to distribute the sign, right, across the numerator, because this is essentially like it's in parentheses. So in the numerator, I'm going to get sine of x minus sine of x cosine of x when I distribute. And the denominator is going to be, when I multiply 1 minus cosine x times 1 plus cosine x, I get 1 minus cosine squared of x. Okay, I'm trying to prove that that is equal to 1 minus cosine of x over sine of x. All right, well, so let's see here. I can turn the 1 minus cosine of x in the denominator here into sine squared of x. All right, so let's see. I'm noticing now that I probably didn't want to distribute, but that's okay. I think I'm actually going to undistribute that. let's undistribute that. Oh my goodness. All right, sine of x. I'm just going to take that sine of x back out and turn it into 1 minus cosine of x. I'm just going back to what I had. I didn't really need to distribute because I can see now that I can turn this into sine squared of x. And my target is to have just sine of x in the denominator. And by not distributing the sine of x, I can see now that, well, that allows me to cancel one of the sine of x's from the numerator and denominator. So you can see now that I'm left with 1 minus cosine of x over sine of x. Okay. So again, I'm just always testing, is this equal to 1 minus cosine of x over sine of x? And you can see in this step that indeed these things are equal. 1 minus cosine of x is equal to 1 minus cosine of x over sine of x is equal to 1 minus cosine over sine of x. So Q, E, D. I'm done. All right, we got one more example, and I will meet you in the next video.